Chapter 5, Selection Structures, Browning's Introduction to Programming with Python. Hello everyone. We're going to talk about Chapter 5 right now, which covers selection structures. And if you recall from our previous chapter, we talked about John von Neumann, and we said that one of his things that he talked about was conditional control transfer. And actually, selection structures would certainly fit with that. One of the first ones we want to talk about is the classic if statement, which is a single selection structure. And basically, it's a branching structure. And what this looks for is truth. If it is true for whatever the condition that it is checking for, if condition A is true, then branch off and do something. Otherwise, skip the whole structure and then move on down to the next item in line sequentially in code. So again, these are branching structures, but they ask a question, and it's a Boolean. Is it true or false? Is it true? Whatever condition it's asking. If it is, branch off and do it. If not, move on down. So ask the user to answer yes or no. If the user enters yes, then show the result for yes. We branch off to that. If not, then exit the program. Not showing the result for yes. That code is skipped totally. All right. Try the next hands-on with an if structure. You will note that after the colon, you should tab over one time if your IDE does not do that automatically. So print then is tabbed over one time. Python is very sensitive to tabs. Try that out, hit pause, and then hit play, and we'll move on to the next area in the code. Very good. So you were able to try that out. So in the example, it says input 1 for yes or 2 for no. If you input a 1, a numeric value for a 1, then it'll say you input a 1. If you input a 2 or any other value, it skips it totally. The next item you want to look at, dual selection structures. So there's not just one condition that you're checking for. You input a 1, do something. If anything else, don't do anything. In this particular case, we have two options. It's either going to be a true or a false. Ask the user to enter yes or no. If the user enters yes, then show the result for yes. If the user enters no, then show the result for no. And then exit the program normally. So classically, you might see this as an if-else. Now, one thing that new programmers will run into is they will have a condition after the else. You will not have a condition after the else. It's just else. It's just not true. So if it's true, x is double equals 1, and we have double equal signs for equality, single for assignment. If we're setting something equal to a value, x equals 1. Single equal sign. If it's checking, is this equal to something else? Double equal signs. Most languages adhere to this. Visual Basic does not, based on context. So your mileage may differ depending on the language you're using. But try this next example with if and else, and then we will hit play when you are completed. Very good. So if you input a 1, it says you input a 1. If you input anything else, it says you did not enter a 1. You must have not entered a 1. You entered something else. All right. So try it with the challenge to build and check for a password. Now, you'll need to use with Python 2 raw underscore input to get strings as opposed to input, which will just get numeric values. But Python is really handy. It'll check the entire string and compare it. Most languages do not do that. Depends on the language at hand. But Python's really good about that. So you could have a string like password, all lowercase, and if it was correct, it would check it, check each character, and it would find that it's true. Try the challenge out and see how that works, and then hit resume when you're done. Very good. Let's try out the multiple selection structure. So multiple selection structure is a little different than the if. One condition is true. If else, one of two things could be true. With a multiple selection structure, there may be more than one thing that could possibly be true. 2 or more, 3 or more. Now, with some languages, you actually have a multiple selection structure. With Python, what you actually have is an elif structure. An if, elif, 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 finally an else, last condition. So you can have as many elifs as you want, but if you think about it like this, if it's true that x is equal to 1, you input a 1. Elif, or else if, it's true that x is equal to 2, you input a 2. Else if x is equal to 3, you go on forever. Finally, if you didn't enter any of those values, else. But notice there's no condition after the else. Hit pause right now, try that code out, and we will move on to the next part of the code, or book. Okay, so you've probably seen that this could be possibly handy for error handling, but there actually are some error handlers built into most languages. In Python, it's no different. It has a try and an except error handling condition. What this does basically is if you get to a condition where the code cannot handle what has been entered, it will automatically default to the except as opposed to having the code blow up on the computer, which is certainly what you don't want. So for this example, we have a string called myString underscore number, and we set it equal to 1. Note there are quotes around it so that we know that that's a string. And then we say try. Try and convert it to an integer. And with the int function, as you see it in the code there on the page, it will take a string, strip off the quotes, and look and see if it can find a number in there. If it can find a number, it'll convert it to an integer. And so at that point, test it would be a numeric value and not a string. And then it will print it out, and it'll say, here it is, and it'll print it out. All right, if it can't do that, let's assume that you had, and I want you to try this with a challenge, change that quote 1 quote to be quote a quote. It can't convert that to a number. It won't be able to do its little thing, and it'll hit the accept. No stinking numbers in this string. Hit pause, try that out, and you'll see how that works. Okay, the next example we'll look at is debugging with raise. Raise will stop your code at a certain point. Again, this is Python 2. But what it will do, it will show you an error message when it gets to a certain point of the code. If you've been unlucky with Microsoft Windows, you may have had some errors pop up sometimes where it gives you an exception error, things of that nature. And those are akin to raise commands. These are error handling. Let us assume, for example, that you had a problem that you never expected to arise but could arise. You might have a raise command in there so that when the user received an error, it would pop that up. They could call the support for the software company and say, hey, I received this error. They know right where it was in code. Try that example out if you would, and we will move on from there when you hit resume. Okay, and if you try the challenge, uncomment the if statement, rerun, and see what happens. Hit resume when you're completed with that. Alright, break and continue allows you to stop your code at a certain point. Basically the way this works, break in a looping structure, which we'll get to very soon, but we've got a little peek ahead right here, a for loop, which runs 1 through 3. It'll stop at a certain point, but it stops the code prematurely. Continue will skip one pass of the code, only the pass that it's actually correct on, that it actually finds truth in, but then it will jump past that and move on forward for the rest of the looping structure. Try those two examples out with break and continue and hit resume when you're completed. Okay, very good. So converting from a string to an int, we did that before. We took a string, we converted it to an int. Let's look at it more formally. We can use float and a string value or int and a string value and convert from string values that have numbers back to floating point or integers. So with the hands-on that we see, what this actually does is really interesting. It's removing white space, and this is actually fairly handy. A lot of times you might have some code or a file that you need to go through and parse through or read through and clean up. For example, in the example we see source equals quote space 1 quote. There is a leading blank space there. What we're going to do is we're actually going to remove that because it could be that that causes an error with our processing of a data file or a data set that we're reading in. Try that example out if you would. Note we also have not equal to, the bang equals, as well as double equals, is equal to, or equality. Alright? And then try the challenge out. What happens if the blank space before the 1 is changed to a letter such as a capital A? Hit pause when you are completed. Okay, the last thing we need to look at is the line continuation character. We know that Python is very sensitive to going to the next line. When you are done with a line, it thinks you're done with processing, the whole statement is completed. With most languages, or many languages, you'd have a semicolon at the end of the line, and that would be a line terminator, Java and C++. All right, but with Python, that is not the case. So the way you're going to get to a new line and extend a line, and this is kind of handy if you're trying to print it out on a piece of paper, it's the slash, the backward slash. Try the line continuation character example out that you see, and then hit play when you're completed. Last but not least, we've used pound signs for comments, which are very, very common. However, you can do multi-line comments, which work the same way. It's triple quotes. You use triple quotes, many lines of comments that will be ignored by the interpreter as you want, and then triple quotes again. All right, try that out. But if you want to leave like a whole paragraph of information at the top of your program, you can do triple quotes, whatever you want to say, triple quotes again, and that whole thing will be a block comment. Consider the activities at the end of the chapter. Try out what you've learned with those activities to reinforce your learning, and have a nice day, and we will see you on Chapter 6.